June 4th, 2017. This video is called TEPCO Gives Fukushima an Enema. Now, an enema is defined as a procedure in which liquid or gas is injected into the rectum, typically to expel its contents. Now, not only has TEPCO given the citizens and the country of Japan an enema, they don't give a shit. They're also crapping on the whole world and flushing us down the toilet. You can't make this shit up. We can smell Shinzo Abe a mile away. He's a lying sack of shit. Now, what lies ahead in Japan is in the cattle deaths. They eat grass and uptake cesium. It is spreading island-wide throughout the food chain. They are intentionally spreading it by shipping out radioactive debris and burning it island-wide, and it will kill them, however slowly. Now, who gives a shit about Fukushima? I duty.
You would have to eat 20 million bananas to get the same amount of radiation from a single isotope from Fukushima. But Ken is going to spin it the other way.
We heard about bananas and we shouldn't make the comparison, but I think actually I disagree a little bit. If we look at the radioactivity and the response, these are beta emitters that have similar energies, and so we actually can make some comparisons. But the point here on this slide is that there's much smaller amounts of radiation in the ocean that we can measure than are generally considered harmful to us.
You would have to eat 20 million bananas to get the same amount of radiation from a single isotope from Fukushima. Cesium-137 forecasts showed a near-surface radiation cloud over Texas, and so each one of those isotopes is equal to 20 million bananas. Hot particles bombarded the west coast of U.S. Each one of those particles are equal to 100 million bananas. And hot particles found at 2 out of 3 U.S. monitoring stations during April, all of these are 2011, is equal to hundreds of millions each of these isotopes of bananas. So one isotope is equal to hundreds of millions of bananas. So a single isotope from Fukushima puts out as much energy as the radiation potassium-40 of 20 million. And so bananas shouldn't be in it, obviously. Why is he doing that? Well, here's the reason. And it's pretty startling, probably the most important thing you'll ever hear about this subject, and it'll explain the most. I'll cover it after. You'll probably figure it out, but I'm going to cover it all after just to make sure everybody gets it.
Now, I do want to put this in perspective from health safety. I'm not a health physicist by any stretch, but I do want to point out, and I'll go back to, there are about 12 becquerels of potassium-40 in bananas. There are levels of concern for drinking water in the U.S. It's about 8,000 in those units. They have a regulatory limit of about 90,000. So they're allowed by law to put up to about 90,000 becquerels per cubic meter of cesium in the ocean by the operating license of TEPCO. Our plants have similar things. They're allowed to have certain levels in the ocean. That's because these are considered safe. And what we'll talk about at the last part of my talk is, well, what does that mean also for, that might be safe for your exposure, but what about the uptake into fish that we might be eating? So I'll end my talk with the seafood side.
So there's 12 becquerels of potassium-40 in bananas, and if you eat it, you off-gas 12 becquerels of potassium-40 from your body. It regulates it, just like a thermostat regulates temperature in your house. The map you're looking at is around 1,000 to 1,500 miles offshore, and so I needed to include that to make sure you understand what you're looking at.
But I do want to point out, and I'll go back to, there are about 12 becquerels of potassium-40 in bananas. There are levels of concern for drinking water in the U.S. It's about 8,000 in those units.
The reason you're allowed 8,000 becquerels of potassium-40 in your drinking water is because it's harmless. It's innocuous. You drink it, you off-gas 8,000 becquerels of potassium-40. It doesn't belong in the conversation.
They have a regulatory limit of about 90,000.
So that's 90,000 of potassium-40. And you would off-gas that. That would be extremely high and unusual, but you would off-gas that if you drank that, because potassium-40 doesn't stay in your body and accumulate.
So they're allowed by law to put up to about 90,000 becquerels per cubic meter of cesium in the ocean.
So you're allowed now, all of a sudden, to put cesium in the ocean, but we were talking about potassium-40. See how we just switched that? So it's not legal, because if you had that much cesium in your water, or your tap water or something like that, 90,000 becquerels, you couldn't turn the tap on. You would just get irradiated immediately, because that's insanity, of course, and cesium doesn't travel by itself. It's going to have the uranium, plutonium, and 30 times more strontium. But this is the game he's running, and that's not all. Wait till you get a load of this.
By the operating license of TEPCO, our plants have similar things. They're allowed to have certain levels in the ocean. That's because these are considered safe.
So he says because it's considered safe. It would be if it was potassium, but what he switched to was cesium, see? They took potassium, used those numbers for cesium, and now he says it's safe to release it. The licensing agreement for all nuclear plants is they're supposed to put this in a sarcophagus, in a man-made structure, not in a hole in the ground, but in a man-made structure where it sits for a couple of 100,000 years. Now he's claiming because it's equal to potassium-40, right? They flipped it. But then he says cesium. And that's what makes it so dangerous. That's what makes this so scary, is they have to lie and manipulate potassium-40 into the conversation to come up with those numbers. That's what makes this so vital, that they can't keep doing this. We have to stop that. That's how they're getting away with it. That's how they're destroying the entire planet. And if there was anything safe about it, they wouldn't be using potassium-40 in the equation. They would just say it's harmless. We know it's not. We know they're supposed to lock it up. We know it went through a chain reaction and becomes many, many times more dangerous and lasts for a long time. Certainly not like a half-life. You have to multiply it by 10. So it's not a half-life. It's times 10. And the lies are endless. He even goes as far as to say the ocean is mostly uranium-238. It's not the same stuff that you get from a nuclear reaction. That's how they do this. They name it the same, and then they claim it's the same, but it's not.
And what we'll talk about at the last part of my talk is, well, what does that mean also for, that might be safe for your exposure, but what about the uptake into fish that we might be eating? So I'll end my talk with the seafood side.
And he says it's safe for your exposure, and then we'll talk about how is it for the fish. So he equated it all with bananas, and then he's going to equate it as harmless also for the fish. That's an outright lie. He shouldn't be at this. He only showed up the minute Fukushima happened.
So this event happened. I had actually moved out of this field, but when we heard about the accidents, we immediately knew we had to get there. And this is just a picture of a ship from the University of Hawaii. We were very fortunate to find very quick funding. This is in June of 2011.
He was there at Chernobyl, didn't do nothing for that entire time, and then he shows up for Fukushima all of a sudden. If that doesn't raise your suspicion that he's now saying potassium-40 is the equivalent of these isotopes, when that's impossible, and it's an outrageous lie, and he knows the difference, but he's going around giving all these lectures and getting all that airtime, and that makes it a scary, scary, scary thing that they have to lie like that.
And that applies to both things like cesium or potassium-40.
Scientists fear Fukushima radiation is hitting the U.S. and it's to worsen. A lot of people are very concerned. Experts, billions are being exposed. Guys, that's not just the United States. Reactors will continue to pour water into the Pacific for the rest of time. They were saying that it could be years, even hundreds of years, but now to the end of time, because they have complete meltdown. And you have a water system that it runs underground, comes out of the mountains, runs underground into the ocean, and it ran under Fukushima. It couldn't have been built in a better place if you wanted to create a worldwide disaster where a third of the oceans are almost dead and will now surely die. If you don't think time is very quickly possibly coming into an end as far as the way we know life, you may be sadly mistaken with this news.
Endless lies. Just endless. Lie, non-stop. That's their legacy. It's never told the truth once. Not a single time. Not one freaking time have they told us the truth. Fabrication, misdirections, misrepresentation, and outrageous, deadly, vicious lies.
Japan's former Prime Minister has accused current Prime Minister Shinzo Abe of lying about the situation being under control. And Abe is widely criticized for encouraging 6,000 residents around Fukushima to return to their homes, and many won't go back.
Even if we come back here, we won't be able to work in the fields. We won't be able to grow rice. We won't be able to pick the wild vegetables either. It will be the same for seafood and river fish. There are no positives.
Every time it rains, every time the wind blows, every time leaves fall off trees, that severe radioactive contamination is washing down from the mountains into the rivers, into the ocean. This is a part of the landscape now, and these places should not be lived in, and yet Abe is trying to force people back into these contaminated zones.
The Japanese government says Fukushima will be safe by 2020. It will hold the Olympic baseball and softball in the Fukushima area to show Japan is cool, even if its melted reactors are still dangerously hot.
So this report from TEPCO seems serious, maybe even ominous. What exactly is going on?
Well, they are exploring the molten core of the reactor in reactor number 2 with robots. And the robot called Scorpion went farther into the bottom of the reactor in an area called the pedestal on which the reactor kind of sits, and measured much higher levels of radiation than before. The highest level was 73 sieverts per hour before, and this time they measured a radiation level more than 7 times higher. It doesn't mean it's going up, it just was in a new area of the molten core that had not been measured before.
It sounds to me like it's problematic that 6 years after this meltdown, there's such a high reading.
It is a very high reading. They may encounter even higher readings. The difficulty with this high reading is that the prospect that workers can actually go there, even all suited, becomes more and more remote. Robots are going to have to do all this work. That was mostly foreseen, but the radiation levels are so high that even robots cannot survive for very long. So now they're going to have to go back to the drawing board and redesign robots that can survive longer or figure out how to do the work faster. And it's going to be more costly and more complicated to decommission this site.
Remind us, Arjun, please, of the human impact of this kind of radiation. What's toxic to humans?
Right. So if you get high levels of radiation in a short period of time, 4 sieverts is a lethal dose for about half the people within 2 months. So in 530 sieverts per hour would give you a lethal dose in less than 30 seconds.
Wow.
So it's a very, very, very high level of radiation. That's why people cannot go into the reactor and work there. And that's not the end of the bad news, but that's quite a bit of it.
Okay, and all right, there's more bad news. I'm sitting down. Tell me.
Yes. So at the bottom of the reactor, under the reactor, there's a grating, and then under the grating, there's the concrete floor. And what this robot discovered, it was supposed to go around the grating and survey the whole area, but it couldn't because a piece of the grating was deformed and broken. So now it appears that some of the molten fuel may have gone through the grating and maybe onto the concrete floor. We don't know because even robotic surveys are now difficult. And high radiation turns into heat. So the whole environment around the molten fuel is thermally very hot. And so whether it is going through the concrete, whether it is under the concrete, I don't know that we have a good grip on that issue.
So, Arjun, what's going on with reactors 1 and 3? There have been published reports that TEPCO, Tokyo Electric Power Company that has these reactors, hasn't really taken a good look at those reactors. What do you know?
Well, they have to develop the robots, and I think they're developing them by looking at reactor 2, and they're finding these surprises, radiation levels much higher than previously measured. It shouldn't actually be unanticipated. The big surprise here was that a part of the grating was gone, and so that the molten fuel would possibly have gone through the grating. So I think similar surprises will await reactors 1 and 3 because each meltdown will have a different geometry.
So now what about the decay products here? You know, we're starting with the uranium family, but we wind up with cesium and strontium 90. What risk is there of strontium-90 getting into groundwater there?
Yeah, so the peculiar thing about nuclear reactions is the initial fuel, uranium, is not very radioactive. It's radioactive, but you can hold the uranium fuel pellets in your hand without getting a high dose of radiation. After it's gone through the nuclear reaction, fission, that's what generates the energy, the fission products which result from splitting the uranium atom are much more radioactive than uranium. And strontium 90 and cesium 137 are two of the products that last for quite a long time, half-life 30 years, and are quite toxic. So strontium 90 is especially a problem when it comes into contact with water. It's mobilized by water. It behaves like calcium. So if it gets into, like seawater, it'll get into the fish, the bones of the fish, or human beings, of course, it gets into the bone marrow and bone surface, increases the risk of cancer, leukemia. So it's a pretty nasty substance. And strontium 90 has been contacted with water. Rainwater goes and contacts the molten fuel. Groundwater may be contacting the molten fuel. So we have had strontium 90 contamination and discharges into the ocean. They also collect the water. They've got about more than 1,000 tanks of contaminated water stored at the Fukushima site. By my rough estimate, maybe about 100 million gallons of contaminated water is being stored there.
What happens if there's an earthquake?
That's exactly right. So about a week into the accident, I sent a suggestion to the Japan Atomic Energy Commission that they should buy a supertanker, put the contaminated water into the supertanker, and send it off elsewhere for processing. They do have a site in the north of Japan, which was supposed to be for plutonium separation, but it could be used to support the cleanup of Fukushima. But they rejected that proposal more than once and decided to build these tanks instead. They have a decontamination process on site, and there are a very vast number of plastic bags on the site filled with contaminated soil. Nobody wants this stuff, and nobody knows what's going to happen with it.
It's 6 years after the original meltdown. How much of a disaster is Fukushima today?
Well, Fukushima is possibly the longest running continuous industrial disaster in history. It has not stopped because the risks are still there. This is going to take decades to decommission the site. And then what is going to happen with all this highly radioactive waste, especially the molten fuel? Nobody knows.